Good morning. I'm going to discuss about the topic association rule mining and classification. First, coming to association rule mining, it's finding interesting associations and the relationship among large sets of data items. These rules shows how frequently item set occurs in transaction. A typical example is market basket analysis. Market basket analysis is one of the key techniques used by large relation to show association between items. It allows retailers to identify relationship between the items that people buy frequently, and then we can find rules that will predict the occurrence of an item based on the occurrence of the other item in the transactions. Um, Before we starting defining the rules, let us first see the basic definition, that is support and count. In this association rule, learning is a type of unsupervised learning techniques that checks for the dependency of one data item to the another data item and mapping accordingly so that it can be more profitable. It tries to find some interesting relations or association among the variables of data sets. It is based on different rules to discover the interesting relationship between variables in the database. The association rules is one of the important concept of the machine learning. Next important concept of machine learning, and it is employed in market basket analysis, web usage, mining, continuous productions, etc. An example of a supermarket, as in the supermarket, all products that are purchased towards are put together. For example, if a customer buys bread, he most likely can also buy butter, egg or milk. So these products are stored within a shelf or mostly nearby. So this is the combinations of products which we are buy together in the supermarket. This is the one of the market basket analysis diagram. And association rule learning can be divided into three types of algorithms. One is a priori, E count, and FP growth algorithm. And then how association rules work. Can concept of if and else statement, such as if A then B. Here the if element is called antecedent and then statement is called consequent. These type of relations where we can find out some association or relation between two items is known as single cardinality. It is all about creating rules, and if the numbers of item increases, the cardinality also increases. So to measure the association between thousands of data items, there are several metrics. These metrics are given below. One is support, confidence and lift. Support is the frequency of A and how frequently an item appear in the data set. It is defined as a fraction of the transaction T. Then contains the item X. If there are X data set, then the transaction T, it can be written as support of X is equal to frequently taken item set of X by T. Next is confidence. This indicates how often the rules has been found to be true, or how often the items X and Y occur together in the data sets. When the occurrence of X is already given, it is the ratio of the transaction that contains X and Y to the number of records that contains X. Confidence is defined as confidence is equal to frequency of X comma Y and frequently taken item of X. Next, coming to lift, it is the strength of any rule which can be defined as below formula. Lift is equal to support of X comma Y by support of X, that is item set, into support of Y. It is the ratio of observed support measures and expected support in X and Y. Y are independent of each other if has three possible values. If lift is equal to 1, the probability of occurrence of antecedent and the consequent is independent of each other. If lift is greater than 1, it determines the degree to which the two items are dependent to each other. Lift is less than 1, it tells us the one item is substitute for other items, which means one item has a negative effect on other. Next, what are the types of association rules? Rule learning is three different types of algorithms there. One is a priori algorithm, LCAT algorithm, and then FP growth algorithm. A priori algorithm is frequently data set to generate association rules, and LCAT is equivalence classification class transformation, and FP growth algorithm is here stands for frequent patterns. And applications of association rules are market basket analysis, medical diagnosis, and protein sequences. In this market basket analysis, same thing we are seen in the combinations of association rule classifications of association rule learning. This is the popular example and applications of association rule mining, and then the medical diagnostics. It helps to association rules with patients can be cured easily as it helps in identifying the probability of illness for a particular disease. Next, coming to protein sequences, that is catalog design and loss leader analysis, and many more applications are there in the association rule learning. Thank you.